we will continue the second part of electromagnetic spectrum, chapter 32. The second type of the electromagnetic wave we want to talk about is infrared radiation. Yesterday we talked about visible light. Today, infrared radiation. Okay? Let's start talking about infrared radiation. Sometimes we write it as IR, infrared radiation. It's emitted by all objects having heat energy or thermal energy. The hotter the object, the more infrared radiation it will emit. Do you remember in thermal physics, we talked about radiation, right? And I told you at that moment that all objects, they are emitting infrared radiation, right? We said all objects emit infrared radiation. But because infrared radiation, we cannot see it with our own eyes, that's why we can't see these waves, okay? But any object, now all of us, even us, our bodies, now all the time they are emitting infrared radiation. But when the object is hotter, it means that the object is emitting more and more infrared radiation. Let's see the cases for objects, different objects, how they emit infrared radiation. Anything or any object which is hot but not glowing, the temperature of it is less than 500 Celsius. For example, our bodies, any object around you now, only emits infrared radiation alone. Normal temperature less than 500 degrees Celsius. At about 500 degrees Celsius, for example here, the heating element of electric fire or toaster. The temperature of them 500, 600, 700 and more. At this moment, what do we have? It's not only emitting infrared radiation and also what? Red light. It emits red light, and that's what we see with our own eyes. Red light from the visible light and infrared at the same time, both of them. The third case, if the object is very hot, about 1500 degrees Celsius. For example, such as what? The filament of a light bulb. Look here, the filament when it glows. It's emitting what? Infrared radiation and white light. White light. White light has what? Visible light. All colors of the visible light. These are the three cases for infrared radiation. The first case, if the object is less than 500 degrees Celsius, only the object emits infrared radiation, the same as our bodies. We don't glow, we don't give color, right? Only infrared radiation, we cannot see it with our own eyes. 500 and more, what do we say? Red, color, and infrared. More than 1500, white light and infrared radiation. Okay. Where do we use infrared radiation? The first one that we all know, this example, which is infrared cameras, which help us to see in the dark. In the dark, we only see what? Colors. We see the infrared radiation. These cameras, they can let us see the infrared radiation that are emitted by different objects around us, okay? Number two, infrared sensors are used on satellites and aircraft for weather forecasting to know the weather, because we know that different temperatures in infrared will give different colors, okay? Here, it means that the object here is hotter than the surrounding, okay? Because we know it depends on the color of the object or of the light from the object. Monitoring of land use, assessing heat loss from building, and locating victims of earthquakes. This is the second use for infrared radiation. The third case, infrared lamps. We use them to dry the paint on cars during manufacture. Okay, look here, all these lamps are what? They are emitting infrared radiation. Why? To dry the paint on the cars. The last use The remote control, you know, the remote control that we all use it for TV, remote control contains a small infrared transmitter to send signals to the device, such as a TV. Okay, these uses, they are very important. You have to memorize them because most of the time in paper 2, they ask questions about uses of each electromagnetic wave and how do we use it. We're done with infrared radiation, girls. We will start ultraviolet radiation. Ultraviolet radiation. Now, ultraviolet, sometimes they say that they write it as UV. Ultraviolet rays, they have shorter wavelength than visible light. Yes, they have shorter. Do you remember why? Why? The sentence that I gave it to you. Rich men in Venus use X-ray guns. So use for ultraviolet. It is after V, Venus, use. So we said while you are reading the sentence, you are increasing the frequency, decreasing decreasing the wavelength. So the ultraviolet, the wavelength of it is less than visible light. Don't forget this note. Now, examples for ultraviolet radiation. The first example that we all know it is what? Ultraviolet rays that are emitted from the sun. Okay? These ultraviolet rays, they can give us what? A suntan or sometimes sunburn. If you stay under the sun for a long time, they cause sunburn. Sunbeds emits ultraviolet radiation. Do you know these sunbeds? Yes. Also, they emit ultraviolet radiation for tan. We use them for tan. Ultraviolet lamps are often used in medical field. So we use ultraviolet radiation also in medical field. How? To help keep disease under control so it doesn't spread. Okay? I hope that everything is clear till now. Now, what we want to talk about? Ultraviolet radiation and fluorescence. What's the meaning of fluorescence? I will explain fluorescence to you girls, but at the end, I just want you to memorize and study this part, the part that you have in the book and the one that you have it here in the video. Now, fluorescence is a property of certain chemicals where ultraviolet light is absorbed and the energy is emitted as visible light. When you see something fluoresce, what does it mean? It means that these chemicals, for example, you know the highlighters that you use them to highlight? Yes, these highlighters are example for fluorescent objects. Okay? So when you see something fluoresce, like the yellow highlighter, for example, the chemicals, they have structures that absorb light from ultraviolet range of spectrum. When these molecules absorb this light, the ultraviolet light that we cannot see with our own eyes, they become excited. The molecules, they become excited, so into a higher state of energy. And what happens? And release most of this extra energy in the form of visible light. And the rest is released as heat. Okay? This is how fluorescence works. But what I want you to understand, only this part, a property of a certain chemicals that they absorb ultraviolet light, they become excited, so they release the energy as visible light. That's why we can see them in dark. Examples, fluorescent paints and clothes. Okay, they look so bright because actually they are emitting visible light after they absorb energy as ultraviolet light array. This effect may be used to verify invisible signatures in bank documents. They use this property in bank documents for invisible signatures. Okay?